Hi, welcome to the Gabster channel. My name is Gabby. I'm pretty excited today to talk about the DAC D11 that I've been building for a while now, and we're getting closer and closer to having it working. I've done a lot of work, as you can see, but mainly today we're going to talk about the power supply unit that's finished, and this video is also finished, so we can get some people watching it. A few people have been asking about it. If you have not seen the other parts, so I'll put a link below, and you can see those to get familiarized with the project. You're going to see a lot of details about how this power supply unit is being built. The schematics, I kept the schematics in a simple way so anybody can understand them, even if they don't have much knowledge in electronics. But please be safe. Do not build things like this unless you know what you're doing, and build those things at your own risk. What's in the power supply unit? Basically, there are the transformers, and keeps all the noisy parts away from the DAC, all the circuitry to turn things on and off, timers and stuff like that. Everything that's noisy is mostly in here. One more thing, if you guys have not subscribed to my channel, please do so. It will really help the channel to keep on going. And please hit the like button for the video. It keeps the algorithm for it going as well. The notification bell in case you want to see all the other episodes that I'll be putting up. And there will be a couple more, at least one where we'll be having finally the DAC going, and maybe one where we're going to do some in-depth testing and in-depth review and comparing the sound and stuff like that. So when you turn the unit on, the unit will basically turn on, and you push the button again, the unit will turn off. When you turn it on, you have the option of having a timer or not having a timer. The timer is, let's say you have a tube amplifier and you don't want it to run 24/7, burn all your expensive tubes. So you could set the DAC to send a signal to the power amp to shut down, say after 4 hours or whatever time you prefer. And if you don't want to use the timer feature, you simply turn it off. The buttons are hidden underneath because you're probably going to set them on once or twice here and there, so I didn't want to clutter the aesthetic part of the unit with that. And there's a couple buttons as well to set the time underneath as well. So off and on, and like I said, the timer goes on and off. And I'm gonna start by showing you all the big detail build of the power supply unit. People wanted to know all the exact specifics about how it was built. If you just want a very general idea about it, in my part 3 I talked a little bit in general, and you can use that part for that purpose. But this part's going to be more in detail. You may not want to build something like this, but there are certain things in the build that might help other projects. You might be building, say, using a timer, using a flip-flop circuit, and how to organize and shield things. So let's get to it, and let's start building that power supply unit. So here you can see the power supply unit. It's pretty much finished. Finally, it took a very long time and got very complicated. It shouldn't have been, but it is. It's always easy when you think, oh, it's going to be just 3 transformers, a couple of things, blah, blah, blah. But when you try to put it in a functional unit, it's a whole different story. So I'm going to work on the socket for the AC outlet. Voilà. So we are going to figure out how to put these transformers. We have 3 of these O-ring transformers, and each one of them will supply, each one has 2 independent outputs of 12 volts. So we can do 5, and the last one, instead of using 2 12 volts, going to use one 12 and one, I believe, 6, and that's going to help power the Raspberry Pi for 5 volts. So we're basically going to put some in here somewhere like this. So 1, 2, and 3. I'm wiring the power supply unit here. So we have, as you can see, 3 transformers. We have fuses. There are about 6 fuses, so each winding has its own fuse, just to be on the safe side, because I'm not running a heavy-duty cable, and just to make sure there's, if any short happens, that I'm not going to have anything melting or any fires. It's always be safe than sorry. There's also a main fuse for the transformers in case the transformer is short. That also will trigger the fuse. The box will be grounded by the ground wire. It's very important that the case is grounded. And that should satisfy all the safety part. So this is an easy schematics. And what you can do is just kept it simple, basically. I didn't want to make it too complicated. I'm just, it's not your typical schematics, but you can see on the right the 3 O-ring transformers. They each have their own dual 12-volt lines, except the third one has a 12 and a 6. So you will notice that there's quite a few fuses, there's some thinner wires, and some people might freak out, oh wow, this is not your typical audio grade wires and fuses. This all is not really important in this case, because all these transformers are doing is charging the ultracapacitors in a very quick brief moment, couple of minutes every 3 to 4 hours. So their job is very limited. Their job is just to provide power, and the DAC is running on the ultracapacitors, and the wires from the ultracapacitors to the DAC portion, all the different components, these are going to be the thick wires, very hardly any fuses in between except for one. So we're going to keep those really short, thick wires and very good quality wires. Also remember that when the DAC is running those 3 to 4 hours on the ultracapacitors, that PSU, that power supply unit, is completely not connected to the DAC. So that's why those wiring and fuses are not very critical. So what activates the power, all these transformers? You'll see that flip-flop circuit. You can get that from Amazon or eBay. I can put a link below. And the flip-flop has a little relay. It's supposed to have a rating of 10 amps, 250 volts, but I don't trust it to power 3 big transformers like that. So I used a very large relay that's going to be powered by the smaller relay. So the smaller relay will send the power to the bigger relay, and the bigger relay is the one that actually starting the transformers. There's a little snubber circuit, and that snubber circuit is basically, it eases up the startup of the power, so there's not a big spark on the relay, so it doesn't get damaged. You can Google that. It's pretty simple. It's a simple resistor and capacitor, and they're all in the little schematic up here. At the top you'll see that I used a very small regular transformer. It's about 13 to 14 volt DC is the one I have, but it was kind of fluctuating with load, so I put a regulator on it to pin it down to somewhere between 10 and 12 volts to supply all the little powers for all the little circuitry that's gonna run, like the flip-flop circuit, all the timers, and all the little small circuits for the VU meter and things like that. So I'm not going to bore you with all the wiring. I'm just going to be wiring all 12 wires. I've got about 15 wires. So I've got a couple extra wires we'll be using for the power switch, and that's going to switch the supply. There'll be some relays here. I will show you those when I get to that. Now I'm working on the control power unit. So I've already mounted the transformers, the fuses, power cable that has all the outputs of the AC voltages coming from 3 transformers. There's 6 basically AC outputs. We'll be also right now working on a this is going to be the control unit, so when you press power, it's going to turn it on and off. And so because there's big transformers, there's a big relay to handle the load. And this is a flip-flop switch, so you push it once, it goes on, push it again, it goes off. You can get those off Amazon, pretty cheap, 10 bucks. And so that's going to be the on-off switch control. And we're going to add another couple of relays here, and one of them is for the trigger in, one of them is for the trigger out. They're opto-isolated, so if anything goes wrong, it's not going to affect your system. Trigger in and out is what it means is, let's say you have a preamplifier, you turn your preamplifier in, your preamplifier will send a signal to your DAC and to turn it on, and that will turn it on, and your DAC will send a signal to your amplifier to turn it on. So it's a chain or reaction where, so you have one button, you push it, everything goes on, you push it off, everything goes off. So that's what this is, and that's going to be all mounted in here to control the power unit. So here you can see on the left, I've added to the schematics the 2 relays, opto-isolated relays. And one is going to be it's a trigger in, and one is a trigger out. And as I said before, basically your amplifier, for example, your preamplifier will trigger the DAC and via the trigger in, and the DAC will send the trigger out to the amplifier, for example, and this will create a chain. So one push button could activate everything. I kept the schematics in a simplified format with pictures. Like I just wanted the people that don't have extensive electronic background to kind of understand and relate and not find it too complicated. So it's done on purpose. Also, you will notice that DB15 cable is basically a cable that has 15 small wires in it, and that's what's going to be, it's like the umbilical cord that's going to go from the power supply unit. It's going to be away from the DAC for keeps the noise, everything away, and it's going to supply the main DAC. The main DAC is also going to have all the ultracapacitors, so it's also is going to have some part of a power supply in it, and that's why it will have another isolated part. The DAC will be isolated within that as well. We'll get to that when we talk about the DAC unit. Just doing the final soldering here. And voila. So here it is. You can see. So this is gonna be. This is the flip-flop. Will trigger the big relay. So small relay will trigger the big relay. There is a snubber circuit, what we call here, and that is to reduce any sparking in the relay and protecting the relay from degrading over time with sparks. And so it's, you can Google it on the internet. It's called the Snubber circuit. And so yeah, so you could see here, like I said, the small flip-flop relay will trigger the big relay. That's the Snubber circuit. It's basically a resistor and a capacitor. I didn't have a big enough capacitor, so I used 2 in parallel. And this is going to be for the trigger in and out. Just keep on wiring here. There is an additional small transformer here that is going to power the small parts that switch the on and off circuitry, and like the LED displays and stuff like that. So I'm just going to wire that, and I'm going to be mounting this guy in here. Got some nice walnut wood. We're going to use that to build the D11 deck. So I've got the front piece here, side pieces. So here you can see the power supply in it. It's pretty much finished. Finally, it took a very long time and got very complicated. It shouldn't have been, but it is. It's always easy when you think, oh, it's going to be just 3 transformers, a couple things, blah, blah, blah. But when you try to put it in a functional unit, it's a whole different story. It got a bit complicated because I really wanted the unit to trigger an amplifier with a 12-volt trigger. So you want, when you turn this thing on, your amplifier to turn on. In case you're running a tube amplifier, which I always pretty much do, I wanted to be able to turn it off after a certain time. So I wanted to be able to have a time delay, and after that the unit will shut down the amplifier. This is an optional timer circuit. I wanted the DAC to activate an amplifier. Sometimes I use a tube amplifier, and I want to activate the tube amplifier, and after a certain time to shut down, and just to save on the expensive tubes that I usually use. So you don't have to use it, but this is there, and I wanted to have the option of having that. And so that's the schematic of the timer circuit. I'll put a link on where you can get that timer circuit. I got it off Amazon or eBay. You can get that. And on the left, there's a small, simple relay. So when the power will be coming from the flip-flop relay, so because it's going to send a little 12 volt to the big relay, from that area it's going to come to this small extra relay, and the relay has a big capacitor. So it's just going to delay, it's just a way to delay the power to going into the timer. And the reason for that is if the power comes instantly to the timer, but when you push the on button, it will go on and immediately it will go off, because the timer wouldn't have started yet properly, and it's going to shut down the unit. So that little relay is just a soft, basically, delay start. And the timer circuit is you want to use program 2.2, and with the program 2.2 the unit will automatically turn on when you have the power activated to the unit. So when you push the on button, within half a second the timer will kick in and will start the countdown, assuming it is on. There's a switch to have it on or off. After, let's say, 3-4 hours, whatever time you set it to, it will the timer will go off. When it goes off, it will send a 12-volt signal through a capacitor of roughly 47 microfarad. And what that's going to do, basically, instead of sending 12 volt continuously, it's just going to do like a very fast 12 volt. It's going to go quick 12 volt, and that's going to activate the flip-flop trigger, and that's going to turn the unit off. And as soon as the unit is off, the timer is also off. And when you turn it on, the cycle goes on again. And as I said earlier, this is an optional circuit. You really don't have to put it in, or you could put it in and not turn it on if you don't need to. There's lots of information on the web on how this timer works and how the programs work. So this is the back of the unit. Here you could see each AC 12 volt output has its own fuse, and at the end they go all run into one of the cable, and it terminates here with the DB15 cable. And you can see on the back we have the trigger in here, trigger out, and a momentary trigger. And this is the AC input. So it's all pretty much simplified here. And just have to plug this DB15 cable into the unit, the main DAC, and that will supply power. Remember, the DAC is running mainly on ultracapacitors, and this cord is only supplying AC lines just probably, I would say, 2-3 minutes every 3 to 4 hours, and mostly it is running on a pure ultracapacitor power. So, and on the other side, this is the cover, the wooden cover that you could see earlier, and it's got there's a little display here that connects to it, and it goes into the unit in here. So what's all this? These are a little bunch of circuits I put together. You can buy them all off Amazon or eBay, except for a couple of things I made myself, but I'll just explain to you quickly what they are. This particular one here is an on-off, what we call flip-flop switch. So basically you push the button, it goes on, you push it again, it goes off. And so it's an on-off switch, and that's going to do the power. And because it's a small relay, although they call it 10 amp relay, I did not trust that little relay to power 3 huge transformers. So this little relay is going to activate the big guy relay here, and that one will activate the 3 transformers. When the relay switches on and off, you don't want it to spark. Transformers have tendency to spark when you first plug them in. You probably have noticed that sometime you're plugging in an appliance and you feel a little spark. And so after a while it deteriorates the switch. To avoid that, I designed a little snubber circuit here. It's basically a little capacitor and a resistance in series. If you Google a snubber circuit online, you can get an idea of what to use for that. So that's going to activate the unit, all these 3 transformers on and off. Then we've got a couple other things here. Here we have a timer circuit, and the timer, it basically, you set the time you want it to go on, and after a certain time it's going to go off. So it's going to trigger a small relay here, and that's going to send a signal to the on-off button to shut it down. So that's the timer circuit. And then we have another relay here, and that is to trigger a momentary something. And that leads us with the trigger in input. So the trigger in is a relay here. This relay, when it senses 12 volts, will click in. Once that clicks in, it sends a signal to here to turn the unit on, and the unit goes on. Here it's just a regulator. This transformer, it says 12 volts, but the old transformers, they always, when you if you don't have a heavy load, the voltage fluctuates with the load a little bit. So there's a regulator here to make sure the voltage stays pinned down to 12 volt. So that's what this thing is. So yeah, this is in a nutshell what goes on. There's a little switch here to turn the timer on and off. I didn't want to clutter the front face, so it's activated. You can reach it from the bottom. And also there's 3 little buttons to adjust the time if you want to adjust it, and also from the bottom. I didn't want them to be visible and clutter the aesthetics of the unit. I try to tie everything up together as neatly as possible. I would call this semi-neat. Could be better, but there's a lot of wires in here. It's amazing how much cabling, and there's a lot of time planning to get all these circuitry to work together. So yeah, so this is the power supply unit. So it's finally finished. It took over probably a month of time and many changes in design just to get to this final design that works. It's always, like I said earlier, it's easy to design something and put it on a wooden board and get it working, but try to design it into a functional appliance is a different story. But this is all shielded, isolated. You know, everything eventually will translate into a slightly better sound. Just gonna turn this thing on. I'm just going to show you part of the reason why I built this. It's mostly for noise. So this is just a noise sniffer. You can see it's very, very low. There's nothing. Even when you get super close to the transformer, look at that. Nothing's happening. It's very low. Those transformers are medical grade transformers. They have a built-in shield around them, and they're not noisy at all, and it makes a big difference. So you're talking about 3 of them here. I'm just gonna. This is the noise by them having them off and turning them on. Not a huge difference. Just a little bit more, but not much more. And once you put that cover on, it's pretty quiet. And so in comparison, I'm just going to show you what a switching mode transformer sounds like. And this is a switching mode transformer. And look at that. And that goes right through the line and everything. So switching mode power supplies, if they're like, they could really ruin your entire line, even though you're not plugged into them. So I would avoid them at all costs. Some of them they're not all bad. Some of them are actually decent. But unfortunately, the majority of them are quite noisy, and I would avoid them. If you have 3 of those in trying to power your unit, you're going to have a lot of noise going through your system, not alone ruining the whole house system as well. I hope you guys liked this video, and if you haven't subscribed, please subscribe, hit the like button, and help the channel and the notification bell so you can hear about the new series, new episodes that I'll be putting up. Especially, you might want to see how this thing ended up. That's going to be the next one. Probably going to be the most exciting, is when I finish building the deck and when we're going to have it actually going. If you guys want to see the videos about the other parts, I'll put a link on the side for the part 1 of this project. From there you can get the other 2 parts. And if you want to know about my speakers, my D11 speakers that I've built, I'll put a link as well on this corner here. So take care, and I hope to see you again in my next video. Bye-bye.